Hello and welcome to another lesson in the Advanced C# course brought to you by your friends here at Tuts Plus. Now it just so happens that this particular lesson is one of my favorites within the .NET framework, and that is generics. And instead of me sitting here and babbling about what generics are and how to use them, let's go ahead and jump into some code and I'll show you exactly what they can do for you. So here we are back in our friend Visual Studio, and I'm going to start by clicking File, New Project, and making sure C# is selected and console application. I'll leave the default name and I'll click OK. So here we are with our boilerplate code, and I'm going to give you a little bit of a background from where I'm coming from and how I kind of came into using this concept of generics. Now, in my day-to-day activities, I do a lot of interactions with external dependencies, and one thing that really starts to bother me is when I have to write a lot of custom code to handle my interaction with one external dependency, whether it's a web service or a data access layer or something like that, and then I have to turn around and write a lot more custom code to handle the interaction with another dependency. And one of the things that really bothers me is when I have to get back some sort of result from these different dependencies, and I have to treat them in different ways in order for me to run my business logic in a way that I see fit. So the thing that I started to do a while ago was create a wrapper class that kind of housed a lot of properties and fields that would give me enough information from these dependencies for me to continue doing my logic, and I could handle these result classes in a very similar, consistent way. So this is kind of how I used to do it. So for each type of return object that I wanted to deal with, I would typically create a public class, and I would call it result. And like I said, in here there would be a number of properties or fields that would help me to figure out what I needed to do next. But to keep it simple, I'm simply going to create two. The first one is going to be a Boolean, and that's going to be called success, which was basically just that high-level flag to let me know, did this operation succeed, and should I bail out of my code, or what I should do with this particular result. And then I would also have some sort of actual property in here that would give me the actual data coming back from those dependencies. So once again, to keep it simple, I'm going to create another property, and let's just say that what's coming back from this dependency or web service or whatever it might be is an integer, and it's called data. So there we go. Now let's say in my code I would call some sort of service or data access layer or what have you, and I would get back this result object. So in this case, I'm just going to new one up, and I'll say this was a new result, and what's coming back from that result is a success equal to true and a data equal to 5. Okay, that's fairly simple. And let's just console write this out so we can see what's going on. Result.success and console write line result.data. So we'll do Control F5 to run this, and as you can see, I get back true and 5, which is exactly what I initialized those properties to in my declaration of my result. All right, no big deal. Well, let's say now I'm calling a different dependency, whether it's a different service or what have you, but this time it's not giving me back an integer type that I need to deal with. It's giving me back, say, a string. So what I would typically have to do is I would have to copy this class. I would copy this. I would drop down a few lines, and then I would change this data type to a string. But I can't leave it this way because you are not allowed to have two types within the same namespace with the same name. So I can't have two result classes. I would have to change this to result int and change my second one to result string like this, and now I could save that, but now I've broken my implementation because there is no result class. So this one would be the result int. Now I can save and Control F5 to rerun, and it still works. Okay, and so now I call my other service or other dependency, and I get a result 2, and that's equal to a new instance of result string. And let's say this time success is equal to false, data is equal to John, and I can save that. And now instead of writing result properties to the console, I'm going to write result 2 just so you can see the difference. Control F5. Oh, I have a build error. Oh, I missed a semicolon. Okay, yep, there it is. Thank you, compiler. Control F5, and there we go. False and John. Beautiful. Well, now heaven forbid you have to go off and call another dependency, and this time you're going to get a new type back. It's going to be a Boolean. So I hope you can see where I'm going with this. I would copy this class. I would create a new result, but this time it's going to be bool, and the data property is of type Boolean. Save that, and on and on and on. This can get very laborious, very boring, and very error prone because once again, we're starting to inject a lot of duplication into our code. And if you've ever heard me speak before or have worked with me before, you definitely know that I can't stand duplication. It's one of those things like nails on the chalkboard that will always get me fired up. And the reason it does is because it really injects a lot of possibilities for you to make a lot of mistakes in your code, not only make it in one place, but in several others as well. And then the worst part of all is, let's say you figure out that there's a bug in code somewhere and you fix it in one place, but there's duplicate code somewhere else and you forget to fix it there, and now you have fixed it in one place and not in another. Or even worse, the opposite way is if you inject a bug in one place and you copy that code somewhere else, now it's gonna break somewhere else. So as you can see, duplication is very evil, and it will haunt you like no other. So wouldn't it be nice if we kind of had a way to remove some of this duplication in these classes here and really just extract or pull out or even parameterize what is the unique part of these implementations? Well, if you stop and don't pay attention to the class names here, but look at the implementations, all of them have the same success property with a Boolean type, and they all have the data property, but the difference is the types of that data: int, string, and bool. So what generics allows us to do is to take a look at those types. Just like we would send parameters into a method or something of that nature, we can now parameterize these types and pass these types into a class or into a method, which we'll show in just a few moments. So let's see what that looks like. So I'm going to select all of these classes and hit Control KC, which will comment them all out. That's a pretty nice trick. And I'm going to clean up my code up here a little bit by deleting it. And let's start from scratch with the same example that we started with before. We wanted to have a Boolean success property and some sort of data property and kind of try to make sure that that's as generic as possible. So we're going to create a new public class, and it's going to be called result, just like it was last time. Now this is where the implementation changes a little bit from the previous examples. I'm going to throw out there an open caret, and what's going to go within these caret brackets is a name that we're going to use in the future to refer to this type within our code, within our class. So we can give this any name that we want, just like a parameter that we're passing into a method. We could call it house or car or tree or whatever we wanted to call it, but it's fairly consistent or fairly common to see it referred to as a single letter. And when you're dealing with generics, it's very common to see them referred to with the letter T. So we'll go ahead and throw that in there for now. And we'll open up our curly braces and close them, and there's our class. So let's start to put our properties back in like we had them before. We had a Boolean, and this was success. And then we had another property, and that was the data. But now what are we going to do with the type? That's where our parameterized type T up here is going to come into play. Instead of explicitly specifying the type of this data, we're going to refer to it generically with the variable T. So now we can save this and build. Everything builds just fine. So let's see how we would use that within our scenarios that we worked with before. So before I was calling out to some service or a data access layer, and I was getting back a result variable, so I'll new one up again. Result. Now you see here that it has the carets in there once again, and this is telling us that this is a generic type that we have to provide some sort of parameterized type to. So let's go ahead and see what that looks like. Now it's going to ask for the type. Now in this case, similar to our previous example, we're going to be working with a data type that, say, is an integer. So we'll specify an int here, and then we'll just initialize these properties: success equal to true, data equal to 5. Now we can once again do our console write line, result.success, and console write line result.data. Control F5 and true and 5, just like we had before. All right, that's pretty nice. Now where this really starts to benefit you is where you now have to deal with a result of a different type. I don't have to touch my implementation code whatsoever. All I have to do is create a new result. We'll call it result2 again, and this is a new instance of the result class, but this time the type is going to be of string, and we have success equal to false, data equal to John. There we go. We'll save that. We'll copy result2, we'll paste it into our write line statements, control F5, and there we go. Now we get the same interaction with that class as we did before, but we only have a single implementation. We don't have to worry about multiple implementations to handle different types, and that is really one of the huge benefits of these generics. Now you might be looking at this saying, well, that's great, but what happens if I have another property in here, say property data2? What am I going to do now if this needs to be parameterized? Well, you handle it in the same way. Only this time, if you have 2, and this time, let's just give it the name u, now I have to specify 2 parameters in here, t and u. Now I can save that. Now this is going to break my implementation because this is expecting 2 generic types. So we'll just say in this case it's an int and a string, and in the second case it's a string and a Boolean. And now we can initialize this in the same way. Data2 is of type string, so we'll call this hello. And data2 in our result2 example is a Boolean, and so I will say that this is true. We'll save that, and I will write another console write line down here, and we'll do result2.data2 and control F5 to run. Now we're getting false, John, true. So we can add as many different properties down here as we need and a number of parameterized types here to map to those different properties. But do keep in mind that just because I have multiple parameterized types within this class doesn't mean I necessarily have to have 2 parameterized types specified in my class definition. Let's say if data and data2 were both of the same type always, I could do both of them of type t, and now I no longer need this u variable. I can save that. Now in my declarations, I only need the one type, so I can get rid of those. And now I just have to make sure that these are of the same type. So data2 here is now 10, and data2 on this side we'll just call doe. And we'll save that, control F5 to run, and there we go, false, John, and doe. All right, that's pretty cool. Well, I hope you're starting to see how these parameterized types for classes can benefit you with working with some of your fields or properties or what have you, but you might be asking yourself, that's cool, but how do I use them in other places? Can I use them in other places? Well, you absolutely can. So let's take a look at this example, and let's say that instead of always writing this to the console, you want to kind of be a little bit more flexible and allow yourself to write that data somewhere else. You could write it to the console, you could write it to a log, you could put it in a database, whatever you wanted. So in order to do that, we would typically extract this sort of functionality into its own method in its own class and only have to change that somewhere else and not have it be dependent on whatever our implementation or whatever our usage of this result variable is. So let's go ahead and try that. So I'm going to create a new class called result printer, and I'm going to open and close my curly brackets, and the point of this class is for me to be able to pass in an instance of my result class and print it wherever I need to print it, like I said before, either to the console or to a database or to a log file or whatever you might want. So I'll create a public method, it'll be a void, and I'll call it print, and I want to be able to pass in this instance of a result. So I'm going to try to do that. I don't know what type I want this to be, so I'm going to leave off the brackets right now, the carets right now, and I'll just call this result. And then I want to do something with that down here. Well, as you can see, if I try to build this, the compiler is going to complain to say, that type requires one argument, and I'm not giving it any. Okay, well, I don't really know what I'm going to do yet, so I'm going to say that this is going to be an integer type. So this is going to be a result of type integer. I'll try to build this. All right, that seems to work out all right. So my implementation in here is going to be a console write line for simplicity again of result.success and console write line result.data. All right, we'll save that. I'm going to dump this data 2 for now just to get things back to a little bit more simpler times. So now we have this result class, or this result variable that I've initialized here. And now I want to create a new instance of my result printer, there we go. And now I want to use it. So I'm going to say helper.print, and I can pass into it a result int parameter. So I'll pass in result, we'll save that, Control F5 to run, and there we go, true and 5, exactly what we specified in our declaration. All right, that's cool. So let's follow that with the second example that we did before, var result 2 equal to new result, and this time it's going to be of string type, and we'll do success equal to false, data equal to John again. Save this, and now I want to be able to pass result 2 in, so let's pass in result 2 and we'll save that. Control F5. Oh, it didn't build. What's the problem here? The best overloaded method for, so basically what this is trying to tell you is that it cannot cast a result with a parameterized type of string to a parameterized type of integer. And the reason that it's saying that is because in our print method down here, we are explicitly stating that we want result with a parameterized type of integer. Now, yes, result is a generic type, but we're not treating it as a generic here. We're treating this as an integer-specific version of that result class. So how can we make this method to be more generic so I can handle it in the same way that I have handled it in the past? Well, that's quite simple. Just like we did our definition of our class of result here with a t, we can do the same thing in this method. So we'll put in a t. So let's try to save this and build and see what happens. Well, that didn't work either because now the compiler has no idea what that t is. It doesn't know what this particular type of t is. And that's because within this context, within this class, it has not seen the generic parameterized type of t. So the way that we kind of warm the compiler up a little bit, if you will, is to specify this t parameter on the name of the method. So now if I save this and build it, it's going to save and build just fine. So now I can hit Control F5, and now I'm getting the result that I would expect. I'm doing the right line of false and John, which is our result 2. So let's switch this back to result 1 and see if it still works. Save, Control F5. And there you have it. It really works again. So you could do this over and over again with different types as long as you're specifying that it's a result class with a single parameterized type. You could definitely pass it into this generic method and treat them all in a very similar way. So this is very powerful stuff here. You get the opportunity to really separate the types from the actual data and still handle them in a very similar way. And that's very, very cool. So I hope you're starting to see how this can really benefit you in removing duplication from your code and really making it much more flexible and allowing you to do some very cool things, some very consistent things, even though you're dealing with different data types. Very, very cool stuff. So play around with this a little bit. I promise you're going to find a lot of uses for it in little places that you might not think of initially. So the more you use this, the more you think about things or try to picture the big picture of what you're trying to accomplish in little ways and how you can really extract some types out of a lot of duplicate code and doing similar processes to how we did before by looking at our classes, looking at some methods and seeing how things are maybe duplicated in there and extracting that stuff and making that very consistent and taking that duplication part, especially when it's of types, and then you can parameterize them and pass them into your classes and your methods. So thank you for joining me in this lesson. I'll see you in the next one.